Hi there, Joshua here. Now people are saying that maths is getting harder, aren't they? People are saying that this year's GCSEs are going to be harder than last year's. And do you know, I think they might have a point because have a look at this. This is a question from this year's specimen paper, just to give us an idea of what the new GCSEs are going to be like. X squared plus 6x plus 4, complete the square. Well, that's the sort of thing we were doing last lesson, so that's a fair question, I guess. But compare that with a question from last year's GCSE paper. Here's part of a square. Complete the square. Hint, use the dotted lines. So a little bit of evidence there to show that the GCSEs are definitely getting harder. Let's start the lesson. Right, so today I'm going to be solving some quadratic equations by completing the square. So I'm going to show you a new method for solving quadratic equations. This is actually the second lesson on completing the square. In lesson 1, I showed you what completing the square is, how to do it. Completing the square is, if you remember, is when you take an expression of this form, a quadratic expression of the form x squared plus something x plus something, where b and c just represent the numbers in the expression. So it could be, for example, x squared plus 8x plus 2. And completing the square is just rewriting the expression in this form, rewriting it as x plus something squared, with maybe a number added or subtracted at the end. So that's what we did in lesson 1. Just to remind you, let's complete the square for this expression here. So let's just complete the square for that expression, just to remind you what we did in lesson 1. So in other words, we're going to write this expression in this form. If you remember from last lesson, I sort of ignore the 2 for now, the number at the end, and I just focus on the front 2 terms. So what does x squared plus 8x go to when you complete the square? Well, it goes to x plus something squared. And if you remember from last lesson, the number in the bracket is always half the number in front of x. So in this case, half of 8 is 4, so that's what goes in the brackets. Now if you were to expand this, if you were to do x plus 4 squared, in other words, x plus 4 times another x plus 4, and expand the brackets, you'd get x times x, which is x squared. You'd get x times 4 and another x times 4, which is 8x in total. But you'd also get 4 times 4, which is 16. And we don't have a 16 over here. So to make this the same as what I've underlined, you need to take away 16. So you always take away this number squared. And now this is the same as what I've underlined. And then I'll stick the plus 2 at the end. So that's basically completing the square. This can be simplified a bit because minus 16 plus 2 can be simplified. So I'll just write it again. X plus 4 squared minus 16 plus 2 is minus 14 overall. So we've done it. We've completed the square. We've taken an expression of this form and we've rewritten it as x plus something squared with a number added or subtracted at the end. So that is what we did in lesson 1. Let's solve some quadratic equations. Now, as I've said already, I'm going to show you a new method for solving quadratic equations today, solving them by completing the square. A quadratic equation is just an equation with an x squared term. And solving a quadratic equation, is just finding the value of x that works in the equation. So finding the value of x that gives both sides of the equation the same value. Now a few lessons ago I did a video on another method for solving quadratic equations, solving them by the method of factorising. And that's normally the first method you learn when you learn how to solve quadratic equations. Now we're not doing this factorising method today, but I just thought I'd put an example up here. Because as I said, that's normally the first method you learn when you learn how to solve quadratic equations. In that method, you start with a quadratic equation. So for example, x squared plus 4x equals 12. And to solve it, step 1, you need to get 0 on one side. So in this case, you take away 12 from both sides of the equation, and you get this line here. And then with 0 on one side, you factorise the expression on the other side. So x squared plus 4x minus 12 factorises to x plus 6 times x minus 2. And by factorising, it makes the solutions much easier to spot. All you do to find the solutions is you look at each bracket separately and you think to yourself, what value of x makes each bracket 0? So what value of x makes this bracket 0? It's minus 6, because minus 6 plus 6 is 0. And what value of x makes this bracket 0? It's 2, because 2 take away 2 is 0. So the two solutions are x equals minus 6 and x equals 2. Most quadratic equations have two solutions. Now if you notice, this method is a very, very quick method. But unfortunately you can't use it all the time. Sometimes you'll have a quadratic equation, like this one here, where the expression just can't be factorised. So this equation here, it's got solutions, it's got two solutions, and we've got 0 on one side, but this expression doesn't factorise. There aren't two whole numbers with a product of 2 and a total of 6. So you need to use another method to solve this equation. For example, by completing the square, which I'm going to show you now. So let's do this new method now, this completing the square method, to solve this quadratic equation. What you do is you look at this expression and you complete the square for this expression. So x squared minus 6x plus 2, we're going to complete the square for that expression. Just ignoring the number at the end for now, just focusing on the front two terms like I usually do. X squared minus 6x, what does that go to when you complete the square? Well, it goes to x plus or minus something squared, and the number that goes here is half of minus 6, which is minus 3. So it goes to x minus 3 squared. But then you've got to take away minus 3 squared. Minus 3 times minus 3, which is 9. So you need to take away 9. And now this is the same as what I've underlined, and then I'll stick the plus 2 on the end. This can be simplified a bit. It simplifies to x minus 3 squared, and then minus 9 plus 2 is minus 7 overall. So we've completed the square. And the reason that helps is because if you notice on this line, x is only in one place, whereas originally it was in two different places. Because x is only in one place, we can rearrange this equation and get x on its own. And you can't really do that here because x is in two different places. So that is why you complete the square, to get x in just one place. So let's rearrange the equation and get x on its own. So to get rid of the minus 7 on this side, you can just add 7 to both sides. And you end up with x minus 3 squared equals 7. Now if x minus 3 squared is 7, how do you find the value of x minus 3? Well, the inverse of squaring is finding the square root. So if x minus 3 squared is 7, then to find the value of x minus 3, you just do the square root of 7. So x minus 3 is the square root of 7, which is about 2.6. Or x minus 3 could be the negative of the square root of 7. Could be the negative of the square root of 7 because a negative number squared is also positive. A negative times a negative is positive. Just to make that a bit clearer, if I gave you the equation y squared equals 9, and I said find the value of y, there are actually two solutions. Y could be 3, because 3 times 3 is 9. But y could also be minus 3, because minus 3 times minus 3 is also 9. So there are two solutions. In other words, y could be the square root of 9, which is 3, or the negative of that. The square root of 9 is 3, so the negative of that is just minus 3. And that's all I'm doing here. If x minus 3 squared is 7, then x minus 3 is either the square root of 7 or the negative of that. Now to find x, in both cases, you just add 3 to both sides of the equation to get rid of the minus 3. So if you add 3 to both sides of this equation, you get x equals the square root of 7 plus 3. And if you add 3 to both sides of this equation, you get x equals minus root 7 plus 3. So those are the two solutions. And they might look a bit strange, but those are the two solutions written in exact form. You might want the answers as decimals, so you could do these on your calculator. You'd have to round the decimals, but 3 decimal places, if you did these on the calculator, this one would be it's 5.646 to 3 decimal places, and this one would be 0.354. 0.354. So these are the two answers to 3 decimal places. These are the two answers in exact form. So that is how you solve quadratic equations by completing the square. And notice it's a much longer method than the factorising method. So if you can use the factorising method, then I'd definitely use it. But if the expression doesn't factorise, you can use completing the square. Right, let's do a few more examples of solving quadratics by completing the square. So x squared plus 8x equals 3. We're going to solve that. Now, unlike with the factorising method, you don't need to get 0 on one side of the equation at the start. So you can leave the 3 on the right hand side and just complete the square for the expression on the other side. So let's do that. What does x squared plus 8x go to when you complete the square? Well, it goes to x plus something squared. And the number that goes here is half the number in front of x, so half of 8 is 4. So it's x plus 4 squared. And remember, you've got to take away 4 squared. You've got to take away 4 times 4, which is 16. Take away 16. So we've completed the square, equals 3. And because we've completed the square, x is now only in one place, so we can rearrange the equation and get x on its own and solve the equation. So to get rid of the minus 16, you can just add 16 to both sides, and you end up with x plus 4 squared equals 3 plus 16, which is 19. Now if x plus 4 squared is 19, how would you find the value of x plus 4? Well, you do the square root of 19. So x plus 4 is the square root of 19, or it could be the negative of that, or the negative of the square root of 19. And normally, actually, we write this in one go. So we write this normally, x plus 4 equals plus or minus root 19. This is saying the same as that, it's just saying it in one go. It's saying that x plus 4 is either positive root 19 or negative root 19. So that's how we normally write it. And to get x on its own, just take away 4 from both sides. So you get x equals plus or minus root 19, take away 4. So again, the two solutions are written there together, sort of in one go. The solutions are x equals plus root 19, take away 4. And the other solution is x equals minus root 19, take away 4. So those are the solutions in exact form. If you want the answers as decimals, you can do these on your calculator. If you do x equals root 19 take away 4, you get, what do you get? You get 0.359. And if you do x equals minus root 19 take away 4, you get x equals minus 8.359. So those are the two answers as decimals rounded to 3 decimal places. Those are the two answers in exact form. Right, I'm going to do another example over here. So x squared plus 5x plus 2 equals 0. So we're going to solve this equation again by completing the square. Notice we've got an odd number this time in front of x. Let's see how that affects things. So let's complete the square. I'm just going to ignore the 2 for now. Just focus on the first 2 terms. So x squared plus 5x, what does that go to when you complete the square? Well, it goes to x plus something squared. Now half of 5 is 2.5. Now last lesson I was sort of encouraging you to use fractions rather than decimals, because fractions are sometimes a bit easier to work with if you don't have a calculator. But because I'm using a calculator today, I'm going to use decimals today. So half of 5 is 2.5. And we need to take away 2.5 squared, 2.5 times 2.5. If you do that on the calculator, you get 6.25. So we need to take away 6.25. Now this is the same as what's underlined. I'll just stick the plus 2 at the end, equals 0. And you can simplify that a bit. So it's x plus 2.5 squared minus 6.25 plus 2 is minus 4.25. So minus 4.25 equals 0. So we've completed the square, which means x is now only in one place, so we can rearrange the equation and get x on its own. So to get rid of the minus 4.25, you just add 4.25 to both sides. And if you do that, you're just left with x plus 2.5 squared on this side and 4.25 on this side. Now if something's squared, if x plus 2.5 squared equals 4.25, how do you find what x plus 2.5 is? Well, you do the square root of 4.25. So x plus 2.5 is the square root of 4.25, or the negative of that, 4.25. 4.25, or the negative of that, which we write like this, plus or minus root 4.25, and then to get x on its own, you just take away 2.5, so x equals plus or minus root 4.25, take away 2.5. Those are the solutions in exact form, and if you want the answers as decimals, so if you use just positive root 4.25, take away 2.5, you get minus 0.438. That's if you just do root 4.25, take away 2.5 on the calculator. And if you do minus root 4.25, take away 2.5 on the calculator, you get minus 4.562. So those are the two solutions as decimals rounded to 3 decimal places. And those are the solutions in exact form. Right, for my final example, I'm going to do an equation where there's a number in front of x squared. So 2x squared minus 8x equals 7. Now you can only really complete the square for an expression that starts 1x squared plus something, so x squared at the front. So if the coefficient of x squared isn't 1, like here it's 2, you can't really complete the square. So what can we do here? Well, because it's an equation, we can get rid of this 2 by dividing both sides by 2. If we divide both sides by 2, this will become 1x squared, and then we'll be able to complete the square. So that's what I'm going to do. I'm going to divide both sides of the equation by 2. So on this side it's going to become x squared minus 4x, and on the right hand side 7 divided by 2 is just 3.5. So again I'm going to use decimals. So because we've now just got x squared, just got 1x squared, we can complete the square, which I'm going to do now. So let's complete the square. So what does that go to when you complete the square? Well, it goes to x plus or minus something squared. Half of minus 4 is minus 2. So that's the number in the brackets, so minus 2. You've got to take away minus 2 times minus 2, which is 4. So you need to take away 4. So we've completed the square, equals 3.5. Again, because we've completed the square, x is only in one place, so we can get x on its own and solve the equation. So to get rid of the minus 4, just add 4 to both sides. You get x minus 2 squared equals 3.5 plus 4 is 7.5. If x minus 2 squared is 7.5, that means that x minus 2 is plus or minus square root of 7.5. So either plus root 7.5 or minus root 7.5. And then to get x on its own, just add 2 to both sides. So x equals plus or minus root 7.5 plus 2. So those are the two solutions written together. And as decimals, if you were to do those on the calculator, if you were to do root 7.5 plus 2, you'd get 4.739. 4.739. And if you were to do minus root 7.5 plus 2, you get minus 0.739. So those are the two solutions. Right, that was the last example. So that's the end of the lesson. So today we've been solving quadratic equations by completing the square. What I'm going to do now, as always, is put some questions at the end of this video for anyone who wants to practice what we covered today, and you can have a go at solving some quadratic equations by completing the square. I'm also going to put the answers after that, so you can pause the video, have a go at the questions, and then look at the answers in that order. Right, here are the questions. Bye.